In data flow architecture, there are 4 types that are used to build a data warehouse, each with its own advantages and disadvantages. Single DDS. It is one of the most basic architectures of any data flow architecture as it only comprises 2 data stores, stage and DDS. It also contains a one-dimensional data store, however it may contain one or more dimensional data marts. It contains ETL packages that extract data from source systems to populate the stage. The stage stores the data temporarily to be processed further into other ETL packages. The stage also minimizes the time to extract data from a source system, which allows the ETL system to process the data in its own time. The physical form of the stage is a database or files because the ETL system either inserts the data into the database or writes them as files. Data warehouse applications, including business intelligence reports, read the data in the DDS and deliver the data to the user. Data in the DDS can also be uploaded into multidimensional databases such as the SQL Server Analysis Services. It is accessed by the users via all-up and data mining applications. Some architecture combines the ETL packages and the stage into one package. The advantage of combining ETL packages into one is having better management over the timing when the data is written and retrieved from the stage. However, the disadvantage is the complexity the ETL package becomes by combination. Here are the advantages and disadvantages of single DDS. Advantage: simplicity in terms of structure. Used for simple, quick, and straightforward analytical buy solutions. Applicable to one source system without using an NDS or odds. Has the quickest ETL run time. Disadvantage: single DDS. The DDS is the master data store. The user would need to build multiple single DDS for multiple source systems. NDS plus DDS. The second data flow architecture is similar to a single DDS but has an NDS or normalized data store installed. The NDS integrates the data from several source systems and loads the data into several DDS. The NDS acts as the master data store that keeps the complete datasets, including all historical transaction data and all historical versions of master data. If there are any changes within the master data, it is inserted as a new record while keeping the old version in the same table. Similar to an OLTP source system, an NDS has 2 types of tables, transaction and master tables. Transaction tables keep business transactions or events, and master tables contain the people or objects involved in the event. A sales order table is an example of a transaction table. A product table is an example of a master table. The transaction table populates the DDS fact table, while the master table populates the DDS dimension tables. The NDS is an internal data store, meaning it cannot be accessed by the end user or application. The only application that can access the NDS is the ETI application. The only time the data is accessed is when the dimensional format is loaded from the NDS into the DDS, letting end users access to the DDS containing the data. In addition, the NDS integrates the same record from different source systems into one record or combines different attributes of the master or transaction data. This allows the DDS ETL to load the data easily because the data is cleaned and integrated, unlike the single DDS. Because of the NDS that can integrate data from different source systems, it can be flexible to create dozens of DDS. Moreover, the developers can use the existing DDS ETL to point at the new DDS by simply parameterizing a set of factors that would fit the new database. Because of the numerous DDS, NDS tables use surrogate and natural keys. Surrogate keys are identifiers of the master data row within the data warehouse and the primary key of dimension tables. This is used to identify unique records within a dimension table, which includes dimension attributes from a specific business transaction. Natural keys are identifiers of the master data row in the source system. This is used to determine if a record exists within the NDS. The natural key does not exist if no records exist. The data loaded into the NDS would require translating the natural key from a source system, then it will be populated into the data warehouse surrogate key. Here are the advantages and disadvantages of NDS plus DDS. Advantage: flexibility to construct and manage multiple DDS. Data is transformed and integrated to specific DDS. Able to rebuild the main DDS. Allows the use of existing ETLs by parameterizing it to specific DDS. Easy trace of data through surrogate keys. Quick data updates. Disadvantage: extra effort to build. Building 2 TL sets due to additional data stores. Odds plus DDS. similar to the NDS, but instead with the use of an odds. There are major differences between the two architectural structures. First, the odds carries only the current version of the master data excluding all historical versions of it. Second, it is a hybrid data store, meaning it is accessible to end users and end user applications. Third, the odds allows end users and end user applications to update and retrieve the data. The source system, however, is off limits of any updates to ensure data quality. Data quality rules are established and end user applications. Only the data generated from the applications can complement the source system's data. In the odds architecture, only one DDS can exist and takes the role of the master data store. Another similarity to the NDS is that some entities can fly through the odds without being staged first for data transformation and integration. The DDS ETL is simpler than the one in the single DDS architecture because the data in the odds is already integrated and cleaned. In the odds plus DDS architecture, there are three formats in three places that applications can access: the odds where data is in normalized form, the DDS, where data in relational dimension format, and the MDBs, where data is in multidimensional format. Advantages: the third normal form is slimmer than the NDS because it contains only current values. The odds plus DDS architecture contains a central place to integrate, maintain, and publish master data. The normalized relational store is updatable by the end user application, making it capable of supporting operational applications at the transaction level. The odds contains detailed, current-valued integrated data that is useful for transactional queries. Disadvantages: the use of one DDS, and to build a new small DDS, the developer would get it from the main DDS. The existing DDS ETL cannot be utilized. Another disadvantage is writing custom queries, as it would go against consistency and standardization. Another is building a new ETL because of the effort to build one, especially in an architecture that would be thrown away.